Silent predators of the sea depths, huge and deadly, capable of destroying not only a city but even a country in a few minutes. Yes, they are nuclear submarines, terrifying the enemy both in wartime and peacetime. They're associated with countless myths, which, however, is not surprising given that they're created in conditions of special secrecy. But today we know enough to tell you in detail about this doomsday weapon. Why don't you make yourselves comfortable and we'll get started? This is going to be very interesting. Nuclear submarines are divided into generations. The first generation submarines built in the 1950s are characterized by relatively high noise and imperfect hydroacoustic systems. The second generation was built in the 60s and 70s. The shape of the hull was optimized to increase speed. The third generation appeared in the early 80s and is characterized primarily by a significantly increased displacement, increased autonomy, and improved crew life, as well as the unification of submarines and their classes. American boats like Ohio and Los Angeles received reactors that work without recharging for up to 11 years and do not require major repairs during the entire life cycle, up to 30 years. The fourth generation is currently the most modern, having started its history in the early 90s. In the USA, it's represented only by multi-purpose types. In Russia, the fourth generation is represented by 3 boats of the ship submarine ballistic nuclear class of the Bore project. These vehicles are united by the use of water jet propulsion, as on the submarine Seawolf Project 955, which is considered the most perfect in the world. Sound-absorbing coatings of a new type, new materials, long-life reactors. After a series of disasters in the previous generation of submarines, the projects received their own autonomous escape pods and a fully isolated reactor. Armament increased and was standardized, thus American boats learned to store up to 50 cruise missiles of the main types used by the U.S. Navy. The promising fifth generation exists only on paper. We'll talk about it at the end of this video. Nuclear submarines have a classification according to their purpose. The first class is Ship Submarine Ballistic Nuclear, abbreviated as SSBN. These submarines carry ballistic missiles with nuclear warheads on board. The main targets of such ships are military bases and enemy cities. In America, boats of the Ohio type belong to this class. Each carries 20 Trident II D5 ballistic missiles on board. Trident II D5 missile is equipped with 2 types of warheads, the W-76 with 100 kilotons and the W-88 with 475 kilotons. At maximum load, the missile is capable of throwing 8 W-88 or 14 W-76 blocks to a range of 7,360 kilometers. The Ohio has a maximum submerged speed of 25 knots. The Russian Bore has 16 Bulava missiles, each carrying 10 warheads with a yield of 100 to 150 kilotons each. The boat's maximum submarine speed is 29 knots. The second class of nuclear submarines is multi-purpose submarines or ship submarine nuclear, abbreviated SSN. Their main armament is cruise missiles and torpedoes. The most striking representative of this class is the American boat Seawolf, which has on board up to 50 cruise missiles such as Harpoon or Tomahawk. The underwater speed of the missile carrier is up to 35 knots, but because of the huge cost, each such boat costs $4.3 billion. The U.S. has only 3 such vessels. More widely represented in such a class are boats of the Virginia type. Depending on the series, they can carry from 12 to 24 Tomahawk cruise missiles on board. The maximum underwater speed of the boat is 34 knots. And now actually about the design of nuclear submarines. They have a nuclear propulsion system, which makes the autonomy of an underwater cruiser much higher than that of a diesel-electric submarine. The range of missions is also greatly expanded. The Americans and British have stopped using non-nuclear subs altogether. In general, only 5 countries have nuclear subs. In addition to the United States and Russia, France, England, and China are in the club of the chosen ones. The rest of the maritime powers use diesel-electric submarines. The most advanced nuclear reactor for submarines is considered to be the S-6W reactor installed on Seawolf-type subs. It has a thermal output of 300,000 horsepower and a shaft power of 57,000 horsepower due to 2 steam turbines. The reactor can utilize natural circulation at most of its full power without coolant pumps, which greatly reduces noise from the boat. The number of nuclear submarine accidents is interesting to look at. A total of 8 submarines have sunk in the history of the nuclear fleet. 4 Soviet, 2 Russian, and 2 American. Only one, USS Thresher, serial number SSN 593, due to hull damage. The infamous Kursk, lost in 2000 during exercises, was the most famous disaster of the Russian Navy and hardly the only accident due to armament. An experimental torpedo exploded on board. Others sank due to direct or indirect propulsion problems. Russian and American boats differ in their architecture. The U.S. makes its nuclear submarines single-hulled, and Russia makes theirs double-hulled. In this case, there's an inner rough, rugged hull and an outer streamlined, lightweight hull. For example, on Project 949A anti-nuclear submarines, which included the already mentioned Kursk, the distance between the hulls is 3.5 meters. It's believed that double-hulled boats are more survivable, while single-hulled boats, all other things being equal, have less weight. In general, there's a tendency to switch to single-hull nuclear submarines as the latest steel used in the hulls of American boats allows them to withstand enormous loads at depth and provides the submarine with a high level of survivability. In particular, we're talking about high-strength steel of HY80-100 grade. Obviously, even more advanced materials will be used in the future. The hull of the boat is divided into compartments, depending on the design, and can be from 4 to 9. For example, on boats of Ohio type, there are 4 of them. Of greatest interest is the second compartment, which has 24 missile silo launchers penetrating the compartment over the entire height. The silo is closed at the top by a hydraulically operated lid. The lid seals the shaft and is designed to withstand the same pressure as the solid hull. A special locking mechanism provides protection against unauthorized entry. A starting cup is installed inside the shaft, which is covered by a membrane that prevents water from getting inside when the lid is open during startup. The membrane is dome-shaped and made of phenolic resin reinforced with asbestos. When the missile is launched with explosive charges, the membrane is destroyed into a center and several side pieces. The Ohio is fitted with the Mk-98 firing control system, which allows all missiles to be put into a 1-minute launch-ready state within 15 minutes. During pre-launch preparation, the system calculates firing data, inputs it into the missile, performs pre-launch checks, and performs launch readiness control. During pre-launch preparation, the Mk-98 computer system can redirect all missiles simultaneously. Before launch, an overpressure is created in the silo using a powder pressure accumulator. The gas produced by the combustion of gunpowder passes through a chamber with water, partially cooled, and enters the lower part of the launch cup, pushing the rocket with an acceleration of about 10 Gs. The rocket exits the shaft at a velocity of approximately 50 meters per second. As the rocket moves upward, the diaphragm ruptures and the shaft begins to receive seawater. The shaft cover closes automatically after the rocket exits. Water's pumped out of the shaft into a special replacement tank to keep the submarine in a stable position and at a given depth. The gyroscopic stabilizing devices are controlled and water ballast is pumped. Missiles can be launched at 15 to 20-second intervals from a depth of up to 30 meters at a speed of about 5 knots and at sea waves up to 6 points. All missiles can be fired in one salvo. In normal mode, engine activation occurs at an altitude of 10 to 30 meters above sea level. The high accuracy of Triton missiles allows for hitting the entire range of high-strength targets such as silo launchers and deep command posts. The long range of defeat allowed boats such as Ohio to carry out a duty in the Atlantic and Pacific Oceans in the zones of domination of their naval forces, which provided them with high combat stability. The high efficiency and relatively low cost of maintaining submarines armed with Triton missiles have led to the fact that the Maritime Strategic Forces occupy a leading position in the U.S. nuclear triad and ensure the deployment of 2,116 out of a total of 3,492 warheads, which is 60%. In multi-purpose nuclear boats, instead of launch silos, universal launching devices with drum magazines for launching torpedoes, cruise missiles, and surface-to-surface missiles are installed. We said above that, the presence of a nuclear reactor dramatically increases the duration of autonomous navigation of the submarine. It's believed that the duration of an autonomous voyage, as a single voyage is called, can reach 6 months. Many of today's nuclear submarines can stay underwater for up to half of this time, and the entire period without replenishment from either shore or support vessels. Nevertheless, the average campaign period of the submarine fleet of all states is about 2 to 3 months. And the main limiting factor here is not the air reserve, as one might think. Indeed, its consumption is enormous. There are 150 to 160 crew members on board. Plus, air is used to blow water tanks for surfacing and to push torpedoes out of torpedo tubes. But the air in a modern nuclear submarine is extracted right on board using water electrolysis. The main deterrent to long autonomous cruises is psychological. It's too hard for a human being to stay in a confined space for a long time with a limited team. Finally, it's time to talk about the future of nuclear submarines, about the fifth-generation boats. It's pleasant to state that in this matter, the United States is overtaking its main rival in this field, Russia. If the Russians are only going to create boats with a modular reactor made in a separate compartment, not requiring maintenance for all 40 years of the boat's operation, and with an autonomous rescue capsule for all crew members, then in the American Seawolf, all this has already been realized. It's already clear that the duplication of reactor systems will remain, and the main propulsion will be a water hammer controlled by a secondary electric motor during main operation and directly by the reactor turbine on the high-speed march. We should also expect fully automated control systems which will allow us to concentrate the crew in one most protected module without the need for constant transitions to working compartments. And of course, these underwater killers will be equipped with even more deadly weapons, hypersonic missiles. The Russian project Poseidon 2M39, or according to NATO code designation, Canyon, deserves special words. It's a torpedo equipped with a nuclear propulsion system and a megaton-class nuclear warhead. There's no reliable information about its characteristics. Various sources named its length as 16 to 24 meters, diameter is 1.5 to 2 meters, and mass is about 100 tons. The apparatus will reach speeds of up to 70 knots and move at a depth of up to 1,000 meters. The purpose of Poseidon is to cause guaranteed unacceptable damage to coastal areas through extensive radioactive contamination and other destructive factors. However, many experts note the inexpediency of such a nuclear torpedo in the context of the existing strategic nuclear arsenal, which more effectively solves the stated tasks. Practical scenarios for using the Poseidon are not obvious. Missile weapons are faster and more accurate, while the vehicle may take up to several days to cover the distance to the coast. This also suggests that the authorities of post-Putin Russia may abandon the Poseidon and similar developments to normalize relations with Western countries. And on this major note, we end our story about modern nuclear submarines. Thank you for watching. If you enjoyed the video, give us a thumbs up. Please also don't forget to subscribe to the channel, and we'll see you soon.